Hello everyone, my name is Avdesh Gaur. Welcome to this comprehensive course on Simple Linear Regression. I am a senior data scientist, a speaker, a storyteller and a consultant as well when it comes to bringing insights out of data and presenting the story behind it. In this video, we will understand the fundamentals of Simple Linear Regression and the mathematics behind it. Whether you are a beginner in data science or looking to refresh your knowledge, this video will provide you with a solid foundation. Simple linear regression helps us predict the relationship between two variables. Imagine you own a coffee shop and you notice that higher sales usually mean more profit. You want to predict how much profit you'll make based on your sales. Simple linear regression is like drawing the best straight line through a scatter plot of your sales and profits. This line helps you guess how much profit you might make if you know your sales. It's like finding a pattern that says, for every extra rupee of sales, you'll make about this much more profit. By applying simple linear regression, you can predict future profits based on the number of cups you plan to sell. This can help in planning inventory, staffing, and other business decisions. Let's dive into the mathematics behind the simple linear regression. The easiest way to understand the mathematics behind it is by visualizing the sales and profit using a scatter plot. Here we can see that there is a relationship between sales and profit. But how can we generalize this relationship between sales and profit? This can be done by the best fit line. The best fit line is represented by the equation y is equal to mx plus c. Here, y is the dependent variable, that is the profit that we are going to predict. X is the independent variable, that is the sales. M is the slope of the best fit line, which indicates how much y, that is the profit changes for a unit change in x, that is the sales. C is the y-intercept, which is the value of y when x is 0. The best fit line, or regression line, is the one that minimizes the vertical distances from all points to the line. This line represents the average relationship between sales and profit. But, how do we find this best fit line? Is it line number 1, or 2, or 3, or any other line? Let's figure it out. We use a method called minimizing the cost function, specifically the mean squared error. This cost function is given by the equation 1 by 2 n of the square of the summation of the distance between the predicted value, that is y hat, and the actual value, that is y. Here n is the number of data points. Y hat is the predicted value. Y is the actual value. Our goal is to minimize this cost function so that the difference between the actual and predicted values is as small as possible. But how do we do that? There are two main approaches of minimizing the cost function. The very first one is the brute force method, which involves running the linear regression with different values of m and c until we find the combination that results in the lowest cost function value. But this can be a very time-consuming process. The second one uses the convergence theorem to reach the global minima. This is a more efficient approach where we iteratively adjust the parameters m and c in a particular direction to reduce the cost function. For simplicity, let's assume that the y-intercept is 0. This will reduce the equation and the resultant one will be y is equal to mx. Now all we need to do is to find the value of m such that the cost function is minimized. In gradient descent, we start with initial guesses for m, and then repeatedly adjust the value of m to reduce the cost function. The adjustment is done by either adding or subtracting the product of the slope of the cost function and the learning rate. The learning rate needs to be small. If you take large learning rates, you might jump over the valley, missing the lowest point, and possibly ending up further away or in a pattern where you keep jumping from one side to the other without ever settling down. Whereas, if you take small steps, you descend more carefully, making sure each step brings you closer to the lowest point without overshooting it. We continue this iterative process of adjusting m until the change in the cost function is very small, indicating that we have reached the global minimum. At this point, we have found the value of m that defines our best fit line. The learning rate is crucial in this process. Too large, and we might overshoot the minima. Too small and the process might take a very long time. We have assumed the value of c to be 0 for reducing the complexity. In reality, we need to find the value of C as well using a similar approach of reducing the cost function. Once we have our best fit line, we can use it to make predictions. For instance, if we know the number of cups of coffee sold on a particular day, we can use our regression line to predict the profit for that day. This is done by plugging the sales number into our regression equation, that is y is equal to mx plus c. To summarize, simple linear regression helps us predict a dependent variable based on an independent variable by finding the best fit line that minimizes the cost function. By understanding the relationship between variables, we can make informed predictions and decisions. We've covered the basic concept, the mathematics behind it, how to find the best fit line using gradient descent, and how to use and evaluate the model. In the next video, we will understand the implementation of the simple linear regression using Python. Thank you for taking this detailed course on simple linear regression. I hope you found it informative and engaging. Keep practicing and exploring the fascinating world of data science. Happy learning!